start something not new, but in different way. What will happen if your main system looks like free? We learned before, your main system may be something looks like truss. And we learned how to calculate dead load, live load, and wind load on this main system. Today we will go through how to get your dead load and live load and wind load for free. Most of the steps are the same. We can assume on weight of your structure, W structure, range between 100 to 200 pounds per square feet. Horizontal projection. Horizontal projection means if you would like to use A or A prime, actually we'll use A. Anyway, weight of covering material. We have flexible roof, corrugated steel sheet. You can assume F25 to 50. Incline projection. That means we will use A prime. Rigid roof, if you have concrete slab, then your weight per unit area, gamma TS. Gamma for concrete, you have to remember all the time this number. After you assumed your W steel and W covering, we need to multiply this value by S, and S divided by cosine theta. Your angle theta is this angle. Before doing anything, I would like you to understand what is the difference between incline projection and horizontal projection from structure analysis. Inclined projection, if you have inclined member, your distributed load on this member looks like this. If you have horizontal projection, like live load, on inclined member, your distributed load must be drawn like this. W bound per foot, W bound per foot. What is the main difference between this shape and this shape? Only one difference. Only one difference. If your load is inclined projection, your equivalent force will be W time L prime. L prime is the inclined length of your member. If your load is horizontal projection, that means the equivalent force for this distributed load equal your load W time L. L is the horizontal projection. If you go down to make projection for your member, the horizontal length of your member L, you can get your equivalent force. So we have two different situations right now. This load is horizontal projection. If you go back to the previous slide, I told you the on weight of your structure, which can be assumed 100 to 200 pounds per square feet, horizontal projection. The second term of your dead load, which is the weight of your covering material, is inclined projection. So we have two different situations must be added. So we can add them, but your W for inclined projection must be divided by cosine theta, your inclined angle for your member. each main system serve from center line to center line. So I will multiply your value by S, on weight by S, weight of covering by S, but this one divided by cosine theta to convert from inclined projection to horizontal projection. Then your problem as a structure analysis problem will look like this. Here is your frame. Your own weight is a vertical load, looks like this. This shape means HP, horizontal projection. If you would like to make equivalent force, the equivalent force equal your W time horizontal length of your floor or your roof. Anyway, if you go back a little bit to truss, actually we need to convert our dead load to concentrated load at each joint. So at each joint, which is location of your Berlin, from center line to center line, so we have an area equal S times A. So we can multiply this value by S times A to get your dead load as a concentrated load. For frame, no. Your dead load will be uniform distributed load. So I don't care about what is the area assigned to each Berlin or each location of Berlin. So my concern is this main system has an area from center line to center line with a distance or width equal S. So your value multiplied by S, your value multiplied by S. I added here divided by cosine theta to convert from inclined projection to horizontal projection. So your dead load for frame looks like distributed load, not looks like concentrated load at each joint like truss. Any question? Actually, we don't care, just put in your mind that your dead load is a horizontal projection. I will let you know on RISA how to define horizontal projection, how to define inclined projection. It's very easy. Second case, or second type of load, which is live load. Everything's the same. Did we cover all of this stuff last time? No, this is the first time. Okay. If your slope equal 10 degree or smaller, and also if your roof is accessible or not accessible, then you can decide which value of your live load, 30 or 15. If your inclined angle greater than 10, you can define your live load equal 15 minus 0.5 times each degree over than 10 degree, but not less than 8.5. Anyway, once you get your value of live load, go ahead and multiply this value by S. From center line to center line for each main system, just S. You can get a new horizontal projection distributed load, W live load. Only S. Before, if your main system is truss, we need to multiply your live load by S and A to convert your load to one concentrated load at each joint of your truss. But in frame, it's okay to convert your load to uniform distributed over your beam of the frame. And also, your live load is horizontal projection. Horizontal projection means, from structural analysis point of view, if you would like to make equivalent force to this distributed load, you don't need to multiply by the inclined length. No, horizontal length is enough. Any questions so far? Nothing new except your load is distributed load, not concentrated load like truss. For wind load, until now, many students still have issue with wind load. First of all, based on your height of the structure, we have here windward direction, leeward, windward roof, leeward roof. Before starting, which side under compression, which side under suction? Do you remember? All sides under suction except windward direction. This one will be under suction. That's right?
Yes.
Under suction. Under suction. Except the first phase, which is the front phase of the wind load. If you remember, for truss, your wind load was concentrated load at each joint. Concentrated load at each joint. And we remember, your wind load perpendicular to your surface. So, your distributed load will be perpendicular to this surface and this surface. Okay, how can I calculate the wind load? Regardless your main system is frame or truss, we need to figure out what is the value of P, which is wind pressure. To calculate your P, we need first to calculate QV, equal this number or this equation 0.00256 kz, kzt, kd, v square. Your V, wind velocity, based on where is your structure, what type of your structure, you can figure out what is the velocity of your wind in mile per hour. K, ZT, KD, these factors will be 1. Based on the turn of the area of the land, and do you take wind only or wind with something else like earthquake? The most important factor here is your key Z. You are lucky if your height, the average height of your building within 10 to 15, nothing will be complicated because you have only one value for KZ, 0.85, that's all. But if your height is greater than this one, so we have different value for KZ. So you have to say, hey, from 0 to 15, your value of KZ, and then what is the value of QZ? From 15 to 20, your KZ equal 0.9. So your KZ equal what? From 20 to 25, what is the value of KZ? What is the value of QZ? Remember, the last value of QZ at the mid-height of your structure, you can call it also QH. This value can be called QH at the highest or the average height of your structure. The last value can be called QH. Once you get your QZ, then QZ can be used to calculate your pressure. Your pressure equal QZ GCB minus QH G, C, B, I, all of these expressed is only one value equal plus or minus 0.18. CB based on this table or this table. I'm sorry, this table for windward wall, leeward wall. This one, windward roof or leeward roof based on your angle. Anyway, G equal 0.85, I think.
Yes.
Wind gusset effect 0.85. So you can handle what is the wind pressure on the windward direction at this location. If you are within 15 feet, you have only one value. Equal QZ time 0.85 times CB minus QH time plus or minus 0.18. You can get your value. But if your height here greater than 15, so until 15, you have the first value. After this, you have a different value based on second value of QZ. Okay? For this one, your wind load looks like distributed load, perpendicular to your surface. First term equal QH. Right now we are working at this location. So your value here will be QH. Your value here will be QH. So we have only one value, one constant value, not variable. QH, I know it, GCB, so go back to this table, minus QH time plus or minus 0.18, you will get only one value. This value, wind pressure on this surface. On the other surface, this one, everything will be the same except your value of CB, because you will have different one.
Leeward